2005 National Electrical Code, specifically Section 680.26 BOEM, addresses the bonding of metallic parts in relation to spas and hot tubs. This section mandates that all metal piping connected to a spa or hot tub must be bonded to the grounding electrode system. The point of connection for this bonding must be as close as practically possible to the spa or hot tub. Section 680.26 B2 delves into the bonding of non-metallic parts. According to this section, if electrical equipment is located within 5 feet of the inside walls of a spa or hot tub, then all non-metallic parts of the spa or hot tub that are likely to become energized must be bonded to the grounding electrode system. This bonding connection requires a solid copper bonding jumper. Section 680.26 B3 specifies the size of the bonding jumper. The code states that the bonding jumper must be no smaller than number 8 American wire gauge copper. It is important to consider whether the 2005 National Electrical Code applies to your particular situation. In locations where the 2005 National Electrical Code has not been adopted, an earlier version of the National Electrical Code, such as the 2002 National Electrical Code, will be the governing standard. The 2002 National Electrical Code provides guidance on bonding and grounding requirements for spas and hot tubs, but the 2002 National Electrical Code does not have specific requirements for bonding non-metallic parts of spas or hot tubs. However, Section 680.26 of the 2002 National Electrical Code requires that all electrical equipment associated with a spa or hot tub be bonded to the grounding electrode system. Additionally, Section 250.104 of the 2002 National Electrical Code requires that all non-metallic enclosures for electrical equipment be grounded. To ensure compliance with both the 2002 and 2005 National Electrical Code requirements, a recommendation is to bond all non-metallic parts of the spas or hot tubs that are likely to become energized. This can be achieved by using a number 8 American wire gauge copper bonding jumper connected to the grounding electrode system. Now let's explore in more detail the implications of these National Electrical Code sections for wiring jacuzzis. Fundamental purpose of bonding and grounding is to enhance electrical safety. Bonding creates a low impedance path for fault current, facilitating the operation of overcurrent protective devices like circuit breakers and fuses. Grounding, on the other hand, provides a reference point for voltage and helps to stabilize the electrical system. When dealing with jacuzzis, these safety measures are even more critical because of the close proximity of water and electricity, which can present a significant shock hazard. The 2005 National Electrical Code's requirement to bond all metal piping connected to a spa or hot tub, as stated in Section 680.26 BOEM, serves to minimize the potential for voltage differences between metallic parts. If a fault occurs and a metal pipe becomes energized, the bonding connection ensures that the fault current will flow back to the source, tripping the circuit breaker and energizing the circuit. Without this bonding, a person could come into contact with an energized pipe and experience an electrical shock. Section 680.26 B2 of the 2005 National Electrical Code extends the bonding requirements to non-metallic parts of a spa or hot tub that are likely to become energized. This means that any plastic components that could potentially carry a voltage due to a fault or induced voltage must also be bonded to the grounding system. The reason for this requirement is that even non-metallic materials can become conductive under certain conditions, such as when they are wet or contaminated. By bonding these parts, the risk of electric shock is further reduced. The specified size of the bonding jumper, no smaller than number 8 American wire gauge copper, as per Section 680.26 B3, is important for ensuring that the bonding connection has sufficient ampacity to safely carry the fault current. A smaller wire size could overheat and potentially melt, compromising the effectiveness of the bonding system. When considering whether the 2005 National Electrical Code applies to a specific project, it is essential to consult with the local electrical inspector. The electrical inspector will be able to provide definitive guidance on which version of the National Electrical Code is currently in effect in that jurisdiction. In areas where the 2002 National Electrical Code is still in use, the bonding requirements may be less stringent than those in the 2005 National Electrical Code. However, It is always a good practice to follow the most conservative approach and bond all metallic and non-metallic parts of the spa or hot tub that are likely to become energized. This will help to ensure the highest level of safety for the users of the spa or hot tub. Even though the 2002 National Electrical Code does not explicitly require the bonding of non-metallic parts, Section 680.26 mandates that all electrical equipment associated with the spa or hot tub be bonded to the grounding electrode system. This includes the pump motor, heater, and any other electrical components. Additionally, Section 250.104 requires that all non-metallic enclosures for electrical equipment be grounded. This means that if the spa or hot tub has a non-metallic control panel or junction box, it must be grounded. In practice, this is typically accomplished by running a grounding conductor from the equipment grounding terminal to the grounding electrode system. When making the bonding connections, it is important to use appropriate fittings and techniques. The bonding jumpers should be securely attached to the metal or non-metallic parts using listed bonding connectors. The connection should be made in a way that minimizes the risk of corrosion or loosening over time. It is also important to ensure that the bonding jumpers are properly protected from physical damage. They should be routed in a way that prevents them from being accidentally cut, pinched, or otherwise damaged. In addition to the bonding requirements, it is also essential to ensure that the spa or hot tub is properly grounded. The grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode. The grounding electrode conductor must be sized according to the requirements of the National Electrical Code and must be securely connected to the grounding electrode and the grounding busbar in the electrical panel. The equipment grounding conductors for the spa or hot tub must be connected to the grounding busbar in the electrical panel. These conductors provide a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The equipment grounding conductors must be sized according to the requirements of the National Electrical Code and must be installed in the same raceway or cable as the circuit conductors. When wiring a jacuzzi, it is also important to consider the requirements for ground fault circuit interrupter protection. The National Electrical Code requires that all 120-volt receptacles located within 10 feet of spa or hot tub be protected by a ground fault circuit interrupter. Additionally, the National Electrical Code requires that all electrical circuits that supply power to a spa or hot tub be protected by a ground fault circuit interrupter. Ground fault circuit interrupters are designed to detect small imbalances in the current flowing through a circuit. If an imbalance is detected, the ground fault circuit interrupter will quickly trip, energizing the circuit and preventing electric shock. When selecting a ground fault circuit interrupter for a spa or hot tub, it is important to choose one that is specifically designed for this type of application. These ground fault circuit interrupters are typically rated for 20 amps and have a trip level of 5 milliamperes. In summary, wiring a jacuzzi requires careful attention to detail and a thorough understanding of the National Electrical Code requirements for bonding, grounding, and ground fault circuit interrupter protection. By following these requirements, it is possible to ensure that the spa or hot tub is safe for its users. When bidding on a jacuzzi wiring project, it is essential to accurately estimate the cost of materials and labor. The materials will include the wiring, conduit, fittings, bonding jumpers, grounding electrodes, ground fault circuit interrupters, and other electrical components. The labor will include the time required to install the wiring, conduit, fittings, bonding jumpers, grounding electrodes, and ground fault circuit interrupters. The labor will also include the time required to test the installation and ensure that it is in compliance with the National Electrical Code. In addition to the direct costs of materials and labor, it is also important to consider the indirect costs of the project. These costs may include the cost of permits, insurance, and transportation. It is also important to factor in a profit margin to ensure that the project is financially viable. When preparing a bid for a jacuzzi wiring project, it is helpful to obtain multiple quotes from suppliers for the materials. This will help to ensure that the bid is competitive. It is also helpful to consult with other electrical contractors to get an idea of the prevailing labor rates in the area. Once the bid has been prepared, it is important to carefully review it before submitting it to the customer. The bid should clearly state the scope of work, the materials to be used, the total cost of the project, and the payment terms. The bid should also include a disclaimer stating that the bid is subject to change if there are any unforeseen conditions or changes to the scope of work. When working on a jacuzzi wiring project, it is essential to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses, gloves, and a hard hat. It is also important to de-energize the circuit before working on it. This can be done by turning off the circuit breaker that supplies power to the jacuzzi. Before beginning any work, it is important to verify that the circuit is de-energized by using a voltage tester. The voltage tester should be used to check the voltage between all conductors, including the hot conductor, the neutral conductor, and the ground conductor. If any voltage is detected, the circuit is not de-energized and should not be worked on. Once the circuit is de-energized, it is important to tag it out. This means placing a tag on the circuit breaker indicating that the circuit is being worked on and should not be turned on. The tag should include the date, time, and name of the person who de-energized the circuit. When working with electrical wiring, it is important to use the correct tools and techniques. The wiring should be properly supported and protected from physical damage. The connections should be made securely and should be insulated to prevent electrical shock. After the wiring is complete, it is important to test the installation to ensure that it is safe and in compliance with the National Electrical Code. This can be done by using a multimeter to check the voltage, current, and resistance of the circuit. The ground fault circuit interrupter should also be tested to ensure that it is functioning properly. In conclusion, wiring a jacuzzi is a complex task that requires careful planning, attention to detail, and a thorough understanding of the National Electrical Code requirements. By following these requirements and taking appropriate safety precautions, it is possible to ensure that the spa or hot tub is safe for its users.